we go with the few topics like linear transformation of a quadratic form, orthogonal transformation, canonical form or normal form, and rank of a quadratic form, and index of the quadratic form, signature and nature of the quadratic forms. So these definitions are very important. If we say about linear transformation of a quadratic form, if A is a symmetric matrix and xy are the two column vectors or column matrices, then the transformation y is equals to ax is called as a linear transformation. Here y and x are nothing but two column vectors or column matrices, and A is nothing but a symmetric matrix. So this transformation y is equals to ax is called as linear transformation of a given quadratic form. Orthogonal transformation, if A is an orthogonal matrix and xy are the column vectors, then the transformation y is equals to ax is called as the orthogonal transformation. So in this first case, A nothing but A is a symmetric matrix, then this transformation is called linear transformation. Here A is a orthogonal matrix and this transformation is called as orthogonal transformation. And here canonical form or normal form, this both means the same. So let A x power x transpose A into x be a quadratic form in n variables, then there exists an orthogonal transformation. So this is a orthogonal transformation x is equals to py, where p is a model matrix and which transforms, so this transformation transforms x transpose A into x to the another quadratic form, and that quadratic form will be of the type, or it will be of the form y transpose D into y, where D nothing but diagonal matrix, and this is a quadratic form. So it will be of the form xy y1 square plus x2 y2 square plus x3 y3 square and so on xn yn square. Then this whatever the form we got here, y transpose D into y, and the transformation is called as the canonical form of the x transpose A into x. So this is the first quadratic form we are taking, and we are taking it in n variables. So when we take this, and there exists a orthogonal transformation of x is equals to py, and that transforms x transpose A into x to the another quadratic form, and that quadratic form will be of the form y transpose D into y, and here that y transpose D into y is called as the canonical form of the this A transpose A into x. So here A nothing but D nothing but diagonal matrix. Here we write the eigenvalues, diagonal matrix of eigenvalues, that is called diagonal matrix, and P nothing but model matrix. Here rank of a quadratic form. So the number of the terms in the canonical form of a quadratic form is called as the rank of the quadratic form. The rank is denoted by R. So whatever the canonical form we get, we will have few terms in that. If there are 3 terms, then the quadratic form, rank of the quadratic form is going to be 3. So it nothing but number of terms in the canonical form is defined as the rank of the quadratic form. Terms, index of the quadratic form. The number of positive terms in canonical form of a quadratic form is called as the index of the quadratic form. So in a given in the given quadratic form, the count of positive numbers, positive terms is called as the index. And signature of a quadratic form. So the difference of number of positive terms and negative terms in the canonical form of a quadratic form is called as signature of a quadratic form. So the difference between positive terms and negative terms, it means if the positive terms are 5 and the negative terms are 6, then 5 minus 6 is going to be minus 1. So signature of the quadratic form is minus 1. So in such a way we define the signature. And here we got nature of quadratic form. This is important for 1 mark. And the quadratic form, this is of the quadratic form x transpose A into x. This is said to be positive definite when R is equals to n and S is equals to n. So S nothing but index of the quadratic form. So we discussed index nothing but the number of positive terms in the canonical form, and n nothing but number of variables, As you know, R nothing but rank of a quadratic form. So if rank is equal to number of variables and index also should be equal to number of variables, then we can say it's a positive definite. So in positive definite is nothing but here all the eigenvalues of A, eigenvalues of the matrix A are positive and they are non-zero. And here positive semi-definite, it means if R less than n, it means rank of the quadratic form is less than number of variables and index is equals to rank. Then in this case, it means if all the eigenvalues of A are positive, all the eigenvalues of A are positive and at least one eigenvalue is 0. So in this case also we can tell the given quadratic form is positive semi-definite when eigenvalues of A are positive and at least one eigenvalue is 0. And here negative definite, nothing but if R equals to n, it means rank of quadratic form is equal to number of variables and the index is equal to 0. So index number of positive terms are 0, it means all the terms are negative. So at the time can tell that it is a negative definite, or in case like if all the eigenvalues are negative. So all the if all the eigenvalues are negative and they are non-zero, then we can tell it's a negative definite. And the nature of the quadratic form can be defined as negative semi-definite when R is less than n. It means rank of quadratic form is less than number of variables and index is equals to 0. So or we can tell it as if all the eigenvalues of A are negative and at least one eigenvalue is 0. So in this case also we can tell the given quadratic form is of the nature negative semi-definite. Thank you.